Okay, YouTube, in this video we're going to look at solving rational equations, but specifically in an instance where we're modeling a real-life situation with a rational expression, and where we're going to use both just plug and chug, but also the inverse to our advantage. So taking a look at this here, it says that in section 7.2, example 5, we certainly made a function here, c equals 50m plus 1,000 over m, in which we're representing the average cost. Okay, this is in dollars here, so let's make a note on our model here. Our C is our average cost in dollars. So average costs in dollars is our C value here of making M models using a 3D printer. So M is a number of models, and this is true for both of our values of M here. And so we can see what's happening to the average cost as the number of models goes up and up. What we want to do really though is find how many models. So we're asked to find the number of models, and that must be our M variable. So find M. But how many models must be printed for the average cost per model to fall to $90? So the way this works is we're being given a C value, and we're asked to find a model value here, which means plug in for C and solve for M. So we're going to do this by A, solving an equation, and B, using the inverse of the function. So let's start with this. Solving an equation-wise, we have C equals 50 times the number of models plus an initial $1,000 split up M ways. And the way this works is basically by solving an equation, we're going to see that they literally gave us a cost value. So as we typically do, we just go plug that in for cost and say, now, how many models would make this true? So the way we're going to work with this here, I suppose there are a couple ways we could do it, but one thing I notice is that we have a couple of equal fractions here. So maybe what we do is we run a cross product, and I say 90m, okay, 90 times m is equal to 1 times 50m plus 1,000. So 1 times anything, making it itself, we really get 50m plus 1,000 on the right side, and what I'm going to do is just solve for m then. So solving for m, subtracting it from both sides, we get 40 m's equal to 1,000, and so m must be 1,000 over 40, or at least we could say that, you know, this reduces to 25. So we say models, m equals 25 models. And to answer our question, essentially we're saying that we would have to produce 25 models or more in order for our average cost per model to fall to $90 or below. So this was method A. If we look at method B here, B is asking us to use the inverse of the function. So by using the inverse, let's remember something here. The inverse essentially takes the output of the function and sends it back to the input. So that is to say that we're kind of switching domain and range, but really what we're going to do is solve for m in terms of C. So that is to say, right, okay, we said take the output and send it back to the input here. Really, before we said that our output is the cost if you tell me the number of models. What we want to do is say, if I had the number of models, you know, could we make it in terms of the cost? And so solving for m here, what I want you to see is I suppose we would take both sides times m would be one way we could do this, or do a cross product. But we would get m times the cost equal to 50 times m plus 100 here. And in order to solve for m, this is a little bit interesting here. What we're going to do is we're going to get all of our m's on one side. So minus 50 times m equals 1,000 here. And we're going to factor the m out. And what we end up with is m, after we factor it out, times c minus 50 over 1,000, which comes out to making our number of models always equal to 1,000 divided by c minus 50. And so if we wanted to work backwards and decide, you know, what would be the number of models we have to do now, or what would be the number of models that would have to be produced for the cost to be this, what we could do is we could say, well, when c equals 90, the idea is that we're plugging it in down here for c, and we get the number of models as 1,000 over 90 minus 50, or we, in other words, get 1,040ths here, which comes out to be our 25 models. So in terms of which method is better here, to use an inverse function or to just go ahead and plug in for C and then solve for M, what I want you to see is in either instance, it is valuable to solve for M in terms of cost. So in the first instance, yes, you could plug and chug. If you were going to be plugging in several different costs, many, like, you know, like 3 or 4 or 5, and trying to find the number of models, it might be better then to just go find the inverse of the function, because what you did was everything you did over here except for we just went ahead and solved for m up front.